Good morning, everyone, and welcome to this lecture. This is electric current electricity, and we are dealing with resistance and resistivity. In the previous class, we had seen about resistivity or specific resistance, and we had seen that it is equal to the resistance of a wire whose area is 1 meter square and whose length is 1 meter. R is equal to rho L by A. That is the only formula that we have to remember. Do we understand this? Do we remember this? Yes or no? Resistance is rho L by L. Do we remember this formula, bachu? Do we remember this?
Yes, sir.
We had also seen the formula for resistivity. Actually, resistivity varies with temperature. Because of resistivity varying with temperature, which is given in this blue block, I hope you can see this. That is the reason why resistance depends on temperature for a conductor, and it increases with temperature. The last part of the yesterday's class, we had seen conductivity sigma. Conductivity is the reciprocal of resistivity, and therefore we have this formula where resistance can be written as L by sigma A, where sigma becomes the conductivity. Everyone remembers this, yes or no? That takes us to today's lecture, and we will be dealing with questions on stretching of wire. These are the questions that I have seen coming many times, and we are going to deal with this as a separate topic, stretching of wire. What happens when you stretch a wire? What happens when you stretch a wire? Do you think the resistance of the wire will change if you stretch a wire? You have a wire and you stretch it. Do you think that something will happen? Yes or no? No, yes. Well, resistance. We are now only concerned with the resistance. Do you think that the resistance of the wire will change if you stretch the wire? What do you think, bacha? Does anything help? Does anything change? Yes. Viram, what changes? Tell me. If I stretch the wire, what changes? What will change and why will it change? Why will it change and why will it change? So these are the two diagrams that are there, as you can see. Now this diagram number A, the blue diagram is before stretching, and this green one is after stretching. Now you can see before stretching, the length of the wire is L1 and the area of cross section of the wire is A1. Do we see this? Yes or no? Length of the wire is L1 and area of the wire is A1. Whereas after stretching, you see the length of the wire has become L2 and the area of the wire has become A2. As you can see, because of the stretching of this wire, the length has increased, but something has decreased. Can you see what is decreased? Do you see what is decreased? Length has increased, but what has decreased? Area, sir. Remember, sir, that the volume, we are not creating any volume, so volume should remain constant. So volume of the wire before stretching and volume of the wire after stretching has to remain constant. We are not putting any material inside. We are not putting any material, so volume cannot change. volume remains constant. That means I can write A1 into L1 will be equal to A2 into L2. I hope we understand this, everyone. Yes or no? The volume is constant. A1 into L1 is equal to A2 into L2. Volume has not changed. Volume cannot change. So from this diagram, you can also see that if the length increases, if you stretch the wire and you increase the length, the area of the wire would decrease because the volume has to remain constant. Yes or no? No, yes.
Yes, sir.
Everyone understands this? So, keeping in mind both of these things together, that the length of the wire has increased and consecutively the area of the wire has decreased. If I call the resistance of this wire as R1 and if I call the resistance of this wire after stretching, same wire after stretching as R2, can you find out? Can you find out the ratio of R1, resistance 1 and R2? How will you find out the ratio of resistance R1 and R2? Anyone has any idea about this? How I'm going to find out the ratio of these resistances before and after stretching? What will be R1 equal to, anyone? What will be R1 equal to, anyone? No one knows it?
Rho H by A1.
Rho H. Where do you see H, beta? I don't see any.
L.
How much is that L? What is R1 equal to? It will be equal to rho into L1 by A1. Length is L1. Rho into L1 by A1. What will be R2 equal to? Can you tell me what will be R2 equal to?
Rho L2 by A2.
Rho into L2 by A2. Now if I keep these things together, I can find out the ratio of R1 by R2. What will be the ratio of R1 by R2? The ratio of R1 by R2 will be equal to how much? The ratio of R1 by R2 will be equal to how much? It will be L1 by L2 multiplied by A2 by A1. Yes or no? Yes or no?
Yes, sir.
But A2 by A1, if you can see here, you can find out the value of A2 by A1. How much is A2 by A1? How much is A2 by A1? How much is A2 by A1? There on your screen right now. How much is A2 by A1?
L1 by L2.
It is L1 by L2. That is absolutely correct. So I can put it here. I can put it here and I will have this revolutionary formula that R1 by R2 can be written as L1 by L2 whole squared. Yes or no?
Yes, sir.
Now you can write it in this way, or what you can do, instead of L1 by L2 you can write A2 by A1. Instead of L1 by L2 you can write A2 by A1. Then you shall have this revolutionary formula, A2 by A1 whole squared. Are we able to understand this? Yes or no? No, yes.
Yes, sir.
Now, if I call the radius of this wire as R1, and if I call the radius of this wire as R2, then I can have the relation. Then I can have the relation of R1 and R2 in terms of capital R1, but ratio of resistance in terms of ratio of radius. Can you tell me what will be that ratio? R1 by R2 is A2 by A1 ka whole square. I can write the same thing in terms of radius of the wire. What will be the ratio then? Can anyone tell me?
R2 by R1 whole square.
What is the area of this wire? If I talk about the area of this wire, cross-section area of this wire, how much will that be?
Okay. Pi r square, sir.
So what is the ratio? A2 by A1 whole square. That was the ratio of resistance 1 by resistance 2. How can I write in terms of radius of the wire? I can write it as R2 by R1 raised to the power 4. R2 by R1 raised to the power 4. You can also write it in terms of diameter D2 by D1 raised to the power of 4. So that completes our discussion on this one. We have got a relation. If the wire is stretched, we have got a relation that relates all these quantities together in a very systematic way. In a very systematic way, this is the relation between R1 and R2. In terms of length, we have got the relation. In terms of area, we have got the relation. In terms of radius as well as diameter, we have got the relation. Do we understand this? Yes or no?
Yes, sir.
I'll give you 2 minutes to note this down. Let me know once you are done. So, I guess all of you have completed this. We will move ahead and I will give them in terms of points. Now remember what we are writing as points. We have already discussed this. So if you can remember this yellow equation, everything is going to be fine. If you want to write it in terms of important points, well, if length is given, the ratio of length is given, you can find out the ratio of resistance of the initial wire and the final wire. R1 by R2 will be L1 by L2 square. So, I mean, this is just, I'm taking from that formula and just writing it in terms of an statement. So, if you want to write in terms of statement, this is how you can write it. R1 by R2 resistances ratio will be L1 by L2 square, or sometimes it will given in terms of not area but the radius. It will be R2 by R1 raised to the power of 4. Do we understand this?
Yes, sir.
Note it down, please. All these things are now given in terms of points. Have we noted it down?
Yes, sir.
Now you can write. Take an example of this. It's a very simple example. Now, sometimes what they are going to tell you is the length has become n times, twice, thrice, 4 times. What will be the resistance? You can simply put it in a formula, and once you put it in the formula, you will get R2 will be N square times R1. Do we understand how will you get this if the length become N times? Do we understand this? Similarly, they can give you that the radius is reduced to 1 by n times. In that case, your final resistance R2 will become n raised to the power 4 times of R1. Do we understand this, everyone, bacha?
Yes,
What
sir.
I am saying here? Okay. Please remember this and do not forget this. I'll give you one more pointer. Then I will give you time to note down these pointers. Now, sometimes they give you percentage change. Now this, whenever they give you this percentage change beta, they will give you 1% or 2% or 3%. Basically, this formula for percentage change 1%, 2%, 3%, 4%. If they talk in terms of percentage change, if the length changes by 2%, let us say, the resistance will change by 2 into 2, 4%. If the length changes by 3%, the resistance will change by 3 into 6, 3 into 2, 6%. Do we understand this?
Yes, sir.
So it is 2 times. Similarly, if area changes by, if area increases by x%, if area increase by x%, then please first see what I'm doing. Resistance will decrease by 2x%. Please first understand what I am writing, then I will give you time to write. If area increases by x%, resistance will decrease by 2x%. If radius, now remember, I should not write it this way, because they are not going to increase the area. To increase the area, you have to compress the wire. That will not make sense. So area is going to decrease. That will be the case coming to you. So if area decreases by x%, resistance will increase by 2x%. That is what you remember. If radius decreases by x%, now can anyone tell me, area decreases by x%, then resistance will increase by 2x%. If radius decreases by x%, what will be the percentage change in the resistance?
4x%.
Well done, 4x%. That is very good and very clear. Remember all these points. You will might have one question coming from this topic. Understand it, write it. Once you are done, please let me know. Then let's move ahead and see how we can apply these things that we have studied into potential questions that are going to come in your exam. Let us start with the first question. And the first question looks like this. This question has come many times in many exams. So can I have the answer for this one? If a wire is stretched to double of its length, question number 1. If a wire is stretched to double of its length, find the new resistance. The original resistance of the wire is R. The original resistance of the wire is R. What will be the new resistance of the wire if the wire is stretched to double of its length? I'll give you 2 minutes to give me the answer. So I have an answer for this question. What is the answer?
4R.
The wire is stretched to double of its length. We have already seen the formula. If the length becomes n times, the new resistance becomes n square times. Yes or no?
Yes, sir.
So R2 in this case will be n square times R1. The value of n is given as 2. So the new resistance R2 will be 4 times the original resistance R. So the answer is simply 4 times, and that is the answer that we were looking at. Everyone understands this? Yes or no? No, yes.
Yes, sir.
Okay. Then comes the next question, and the next question is like this. Question number 2. A wire is stretched to increase the length by 1%. 1% is the increase in length. What is the percentage change in the resistance of the wire? What is the percentage change in the resistance of the wire? I'll give you 2 minutes to give me the answer for this one. So we have the answer for this one. We have already seen the formula. The formula relates the percentage change in length to percentage change in resistance. Everyone remember that formula 2x? If the length changes by x%, resistance changes by 2x%. So the percentage change in resistance, will be 2 multiplied by 1. That will be 2%. Everyone understands this? Yes or no? No, yes.
Yes, sir.
Any idea? I mean, any doubt on this one? I hope everyone understands this. Can I have reason that we understand this, sir?
Understood, sir.
Okay. Then comes the next question, and I hope that I can get the answer for this one as well. Again, this question has been repeated multiple times in different examinations, and the question comes on your screen now. Question number 3. If a copper wire is stretched to make it 0.1% longer, what is the percentage increase in the resistance of the wire, my dear friends?
Sir, option A.
Option A is absolutely correct. Length is increased by 1%, so the percentage increase in resistance will be 0.1 multiplied by 2, and that is your answer. I hope everyone has understood this. Yes or no? No, yes.
Understood, sir.
Now there is one more question that I see coming in your medical exams, and this is this one. So let us discuss this one. Masses. Okay, for the first time, masses have come into the picture. Question number 4, I guess. Masses of 3 wires are in the ratio 1 is to 3 is to 5. They are made up of the same material. It is not given, but we'll assume that they are made up of the same material. They are made up of same material, but the masses of the wires are in the ratio 1 is to 3 is to 5. And their length is in the ratio 5 is to 3 is to 1. What is the ratio of their electrical resistance? I'll give you 2 minutes. If you can give me the answer for this one, I would be pretty happy. Your 2 minutes time starts now. So let me help you out in doing it. How are we supposed to do this? We just have to see some simple things. We know the formula of resistance is
Sir,
rho.
option B.
Option B is not correct, beta. Rho L by A. Now A is the area of cross section of the wire. Now if you look at the wire, and if I may draw this wire, this is how I draw this wire. This wire is normally of circular cross section. Now if I call the cross sectional area as A, And if I call the length of this wire as L, the volume of this wire becomes A into L. Yes or no? The volume of this wire becomes A into L. Yes or no?
Yes, sir.
So I can now replace this A by volume. So I can write it as rho L square by V. I have written A as V by L. Yes or no?
Yes, sir.
Similarly, I can write the density, and normally I'll denote density by rho, but rho has been taken, so I use D for density. Density is mass per unit volume. Yes or no? This
Yes,
D
sir.
is not diameter, this D is density. So from here I can write volume as mass divided by density. So now my formula becomes R becomes equal to rho L square divided by mass into density. Yes or no?
Yes, sir.
Now I can find the ratio of their resistance. Now I can find the ratio of their resistance. I have derived this formula. Now I can use this formula. Resistance R1 will be equal to rho L1 square by M1 into D. Resistance R2 will be equal to rho into L2 square by M2 into D. Resistance R3 will be equal to rho into L3 square by M3 into D. Yes or no?
Yes, sir.
So now you can tell me the answer for this one. What will be the ratio of the resistance R1 is to R2 is to R3? R1 is to R2 is to R3 will be equal to L1 square to 5 square by 1, that is 25, is to length of the second wire is 3, so it will be 3 square 9 divided by 3 is to the
1 by 5.
1 by 5. If you just write it in the correct form, you will get the ratios. Yes or no? No, yes. Yes or no? No or yes. Which option are you going to get? 9 by 3 is nothing but 3. So let me not write it as 9 by 3. Let me write it as 3. Option D, sir. That is correct, sir. And that is your option, sir. Option D, sir. I'll give you 2 minutes to note this down. And at the same time, you also should note down this formula. This is resistance in terms of density and length and mass. So you can keep this formula also ready with you. You can also note down this formula. This is in terms of length and volume. Do we understand this? So you can keep these two formulas together with the other formulas of resistance. I'll give you 2 minutes to do this. Note it down, please. Well, I hope everyone has noted this down. That takes us to the next step, and what we are going to write in the next step. We have already gone through Ohm's law. We'll just have a look back again at the Ohm's law. And we've already done this. Why I'm going back to this? Because I want to write another form of Ohm's law. We have seen that Ohm's law, V is equal to IR. Yes or no? V was standing for voltage drop across the resistor. I was the current in the resistor, and R was the resistance of the resistor. We remember this? Yes or no?
Yes, sir.
Now, this is one way of writing this Ohm's law, but there is one more way, the original way of writing Ohm's law. And the original way of writing Ohm's law is this: J vector is equal to sigma into E vector. That is the original form of Ohm's law. You can also call it the vector form of Ohm's law. This is the original Ohm's law from where V is equal to IR has been derived. Now at this point in time, you have to tell me what is this J vector? What is this J vector? What is this J vector here in this equation? No one remembers this J vector? There are only two.
Velocity, sir.
There is only one vector that we have done in this chapter. What is that vector? J vector.
Drift velocity.
Why will I call drift velocity as J? There's no relation. Okay, you've forgotten it. This is the current density. If you remember that current density, we had done a lot of questions on that current density. J vector is your current density vector. I can't go back to recollect it because then I will never be able to finish this topic. Anyways, this J vector is your current density vector. What is the sigma? If you don't remember J, there is no point of me reminding you of sigma. The sigma is the conductivity. That was the last thing that we did in the last class, conductivity, which was the reverse of resistivity. Conductivity. Sigma is conductivity. J is your current density. Current density is a vector. That is what I can remind you of. It is current per unit area. Sigma is your conductivity, and E is your electric field. So please remember this formula of Ohm's law as well. This is the original formula of Ohm's law, which relates your current density with conductivity and electric field. I'll give you 2 minutes to note this one down. Please remember it. Well, since you have noted this down, we have to move to the next topic, next point in this. And the next point in this is what you must be knowing: color coding for carbon registers. Color code for carbon registers. Or color code for registers. Now, what is this color code? Normally, whenever you whenever you have a register, the value of the resistance of the register is not given directly in terms of value. It is given in terms of 4 bands of colors, 4 bands of different colors. Just normally like this, 4 bands of different colors. The first strip is called A, the second one B, third one C, and the fourth one D. Do we understand this?
Yes, sir.
This is how the color coding is given, and based on that color coding you can find out what is the resistance of the given register. Any idea how we are going to find it out? The first code, which is the color A, and the color B gives us the numbers, the significant numbers of the resistance. For example, if the resistance is 42, A will be equal to 4 and B will be equal to 2. Do we understand this? So A and B gives you the color coding. For example, if I have a register which is 45 into 10 raised to the power 3 plus or minus 5%. This is how normally the coding is given. This is how normally the resistance curve value is given. So you can see the color code for A will correspond to 4. Do we understand this? This B will stand for this 5. This C will stand for this 10 raised to the power of 3. And this D will stand for this 5%. Do we understand this?
Yes, sir.
Okay. So this is what that is given in words in what I am now showing to you. You just have to understand. You don't have to write everything. You just have to understand what does A, B, C and D stand for. If you understand this, there is no point of writing what you are seeing on your screens. Do we understand this? What I am saying you, what I am telling you.
Yes, sir.
Everyone understands this. If you understand this, then there is no point of writing the other parts because they are useless. This is what the color coding is all about. The first number is given by A, the second number is given by B, the power of 10 is given by C, and the tolerance or the error is given by the fourth band. Do we understand this? Yes or no? No, yes.
Yes, sir.
Okay, sir. Then, sir, this, sir. Then you have to remember which color means what. Which color means what? Which color means what? Have you noted down that thing? That thing that I gave you? Eh? Have you noted down that stuff?
1 minute, sir.
Okay, I'll give you 1 minute. I have 1 minute. Let me know once you are done. Well, since you have completed, this is the table of the color code which tells us which color means which number. The first color is black, stands for 0, brown 1, red 2, orange 3, yellow 4, green 5, blue 6, violet 7, gray 8, white 9. The short form is B R O Y G B G B. How do you remember this? This is the short mnemonic that you have to remember. B Roy of Great Britain had a very good wife. The first B stands for black. The second B stands for brown. R for red. O for orange. Y for yellow. G for green. Next B for blue, violet, green, and white. On the right hand side, we have the two colors for the D band. Gold stands for 5%, silver stands for 10%, and no color stands for 20%. Do we understand this? Yes or no?
Yes, sir.
Color code and which color represents which number. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down. Well, I hope you have noted this down.
Hmm?
You have to write it in the same order. You just write BB Roy, GB, VB, YW, and then you can make the entire table on your own. Do you understand what I'm saying? Just have to write the last line. Just you don't have to draw the entire table. You just have to remember the last line. Do we understand this?
Yes, sir.
So I'll give this as homework that you can draw this table at home. Just remembering that blue line. Gold stands for 5%, silver stands for 10%. You can remember that, not a problem. So we will do 1 or 2 questions based on this color coding in the next class and we will go ahead from there. Everyone has understood what we have discussed in today's class?
Yes, sir.
Well done. Then we will meet in the next class and go ahead from here. The next class we will be going ahead with series parallel combination of registers. We have already done that. We'll do one or two questions and then we would be gone. Okay, so I'll see you in the next class. Take care. Have a nice day. God bless you all. Bye bye.
Bye, sir.
Bye, beta.